Good morning, students. Today we are talk about the topics of Fibonacci sequence, reversing the digits of an integer, finding the square root of a number. Here, the introduction of the presentation. This presentation covers three mathematical concepts that are Fibonacci sequence, reversing the digits integers, and finding square roots. Each topic will be explained in detail with examples of an application. So let's begin. What is the Fibonacci sequence? The Fibonacci sequence is the series of numbers which that numbers adding two numbers with the processing 1. In middle that two numbers adding it gives the result. It typically starts with 0 and 1 resulting in the sequence. Here 0, 1, 2, 3, 5, 8, 13 and so forth. This sequence is widely observing in nature such as in the arrangement of leaves and in a branching of tree. We have that branching of tree, three leaves tree like this. Next, mathematical formula of a Fibonacci sequence. In this Fibonacci sequence we observe to apply some mathematical formulas, that is the f of n equal to f of n minus 1 plus f of n minus 2 for n greater than 2. So here we apply 0 to n terms. That nth Fibonacci number can be computed using the formula f of n equal to f of n minus 1 plus f of n minus 2. This recursive definition allows for easy computation that Fibonacci numbers. Here observe that is the f of n is the nth term number. So f of n minus 1 is the n minus 1th term number. So here we apply f of base is that number, that term number. An alternative formula knows the Binet's formula, provide a direct way to calculate Fibonacci number without recursion. So here we apply some formulas to calculate the Fibonacci numbers. Applications of Fibonacci sequence. In this Fibonacci sequence, we applications have a computer science, particularly in algorithms and data structures. This Fibonacci sequence we apply in a data structures in algorithms. It is also used in a financial markets for technical analysis through Fibonacci retracement levels. That Fibonacci sequence we use in a financial markets, digital markets, where furthermore the sequence appears in art and architecture after associated with the golden ratio. So we are finally calculate the ratio between the different Fibonacci sequence that are applied in the financial markets. Next, introduction to reversing digits of an integer. So here the reversing digits like this 1, 2, 3 is result when reversing the digit is 3, 2, 1. In addition, multiplications division as a different ways. This reversing digits. The reversing digits is the integer involves changing the order of its digits to create a new integer. So basically it's for example 1, 2, 3, A, B, C. We take it as example. It reversing method will apply. It is a 3, 2, 1 CBA. Like this in operations of integers we use to addition, multiplication, division. Here we observe 2 plus 7 equal to 9. Like this minus 2 plus minus 7 equal to minus 9. So the result will be changing. Here the reversing digits is we recruit the different answer. Next, methods to reverse digits. So here some methods to reverse the digits. One common method is integer is to convert into string, reversing the strings and convert it back to an integer. So here it will we take the one example 1, 2, 3, 4, 5. So here we apply the reversing digits is 5, 4, 3, 2, 1. The another approach is to use mathematical operations such as modules, divisions and extract. So reassembles the digits. The choice of method may be depend on the programming languages and specific requirements. So here we apply the in programming language is in a specific requirements. Next, example of reversing digits. Let's take an integer 4, 5, 6, 7 as an example. Applying the reversing method we obtain 7, 6, 5, 4. So it's just a reversing the digits, reversing the alphabets like this. This simple transformation can lead to intersecting properties and pattern in a numbers. In the computer language, we use it as a algorithms to ascending and descending, arranging the elements like this. Next, applications of reversing digits. Reversing digits can be applied in a cryptography for encoding and decoding messages. So here the messages are for decoding and encoding. In cryptography, we use this the reversing digits method. It may also find use to palindrome checks where numbers are compared to the reversed versions. So here we compare to the reversed versions, we check the palindrome checks. Like box we observe accept the positive integer, reverse the order of the digits. Example, if the number is 1 2 3 4 5, reverse number is 4 5 4 3 2 1. So here it accepts only the positive numbers. Additionally, it can be a fun exercise in a programming challenges and competitions. Next, introduction to the square roots. So in mathematical, we observe here the square roots. The square root number value that multiply by itself. So it's a square root of 1 equal to 1 square root of 2. So it's by itself it multiplied, gives the original number. It is denoted to the radical symbol is a square root. The square root fundamentals in a algebra, many areas of a mathematics, we observe here square roots of 1 to 20. So it's multiply itself. Calculating square roots. The square roots can be calculated using various methods including estimation, prime factorization, and different methods, that is the LCM, GCD. In calculator, computer can also be used to find the square roots quickly and accurately. Here we observe to square root of a 144. So here we divide with the 2. The answer is square root of 144 multiply the, we are using the division is 12. So square root of 144 is 12. Like this we calculate the square roots values accurately. How to calculate square root is the essential for solving quadratic equations. So here main is we have to know the how to calculate the square root. Next, properties of a square root. In the square root of a non-negative numbers is always a negative, is a non-negative. So here we take it as in square roots. If in case there is a non-negative numbers, there is always a non-negative. The square root of 0 is 0 while square root of 1 is 1. When dealing with the negative numbers, the square root is expressed in terms of imaginary number. So when dealing with the negative numbers, just we have to imagine that number to calculate with the positive, and so its negative number is, so we finally answer is a negative value. Next, applications of a square roots. Square roots are used to geometry, particularly in the calculations of distance and areas. So mostly the square root formulas are used to find out the distance, areas of the value. They play crucial role in statistics, especially in derivation calculations, mathematics. In square root and cube roots we observe here. And additionally, square roots are important in a physics and engineering are solving various equations. Here we observe to find out the in physics the area, like volume, like this we find out the values. These topics relationships, Fibonacci sequence can be connected to square roots through the golden ratio. So before we discussing in a Fibonacci sequence, finally we compare to the golden ratio is interconnected with the square roots, which is derived from a Fibonacci numbers. Reversing digits can be interesting operations when applied to a Fibonacci number themselves. So that reversing options we observed in a Fibonacci sequence. These mathematical concept, problem solving skills and analytical thinking. Next, summary of key points. This summary of a key points is what are the Fibonacci sequence and the formulas that what we are applying. Finally, we examine a square root, their calculation, properties and significance in the various fields. The conclusion is mostly used in a mathematics in a vast interaction that would concepts like those we discussed today. Thank you.